CloudDB, shaping your new normal.
Welcome everyone to the 2021 APAC Groundbreakers Virtual Tour by Apaco UC. This year our event will be the biggest one ever done, with 144 sessions, including normal sessions, workshops, and hands-on labs from 100 different speakers over 17 days. Also, it will cover sessions in 4 different languages. Please remember to register to as many sessions as you can. That way you can also watch the replays to all sessions you are registered to until December 30 through the same platform of the event. I would like to say thanks to our Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers, and your main sponsor, CloudDB. Now, for today's session, Running Oracle Databases in Docker Containers by Sean Scott. Please feel free to write questions at any time by using the chat window of live webinar, and Sean will be answering all questions at his convenience. If you have any issues during the transmission, please let me know by using the same chat window, and I will try to do my best to help you the best I can. Now, without any more further ado, I'm going to leave you with this amazing session by Sean. Sean, it's all yours.
Well, that was a lot of pressure right there. Thank you for the introduction, and thank you to all the user groups that are participating and putting this event together. I know this is a huge event, and there's a tremendous amount of work that goes into making sure that it all comes together like this. Welcome to the session. Again, this is a hands-on lab talking about running Oracle databases in Docker containers. Real briefly, an introduction on myself. My name is Sean Scott. I've worked with Oracle databases since 1995 or so. Started out as a developer and graduated to being a database administrator. Ran my own consultancy for about a dozen years and had the opportunity to work on some pretty fascinating projects in there. And so I've seen a lot of different industries and different applications of the database, from 911 systems to logistics and finance, retail commerce, things like that. I've worked pretty extensively as an operations DBA and database reliability engineer, and I had the really good fortune to work in a tremendously well-run DevOps environment that showed me the value of doing things well with your databases and generally doing the value of good engineering and good operations for an organization. Currently, I work as a managing principal consultant for Viscosity North America. A lot of what I do is implementing and troubleshooting RAC and DataGuard, Exadata, high availability systems, migrations and upgrades. And I do a lot of automation in what I do or in my daily job, and work with Docker quite a bit. I'm also an Oracle ACE, and here we go. We'll talk about the workshop itself. Now, all of this, everything that we're going to discuss here, you can run locally on your machine. And I've done this presentation a number of times over the years. And one of the issues that always seems to come up is somebody's running on an operating system that I'm not familiar with, or they go and they have some kind of dependency issue, and they go and they install Docker and they have questions during the webinar and have problems, and so they can't participate. So I decided that I was going to make this a hands-on lab. And so I have a workshop, and I have everything ready and provisioned as Terraform files that we can run in Oracle Cloud Infrastructure. So I want to walk through the steps of doing this real quickly, just so you have an idea of what's going to take place and what you can do. I'll let you go through and run these steps. And while everything is provisioning, I'm going to give you some background on Docker, and then we can get in. And if you'd like, you can go hands-on, follow along with me, and see what it's like to run a database on Docker. Even if you don't want to do this right now, The files and everything will be available till the end of the month, till December 31st. So you can always provision this later and work through the lab exercises and so forth, which are all part of the provisioning scripts. So the first thing that we want to do is we want to create an Oracle Cloud free tier account. Unfortunately, you can't run this in an existing account that has switched into the always free resources, because we need a little bit of a larger server to run Oracle, not to run Docker. You can run Docker all you want, but we need a somewhat more powerful machine or somewhat more powerful resource to run Oracle in the cloud environment. So when you create a brand new free tier account, you still have that $500 credit available to you. And so you can use that to run these resources. Just for an idea of how much this costs to run this, I've done this lab, I think maybe 5-6 times in the last few months. And through the process of provisioning and reprovisioning and testing and everything, I've used $300 of my own credits. So it really is not that costly to run. But again, you do need those resources available to you. So you go in, create that new account at cloud.oracle.com. And once you've logged into that account, we'll navigate over, and I'm going to post this link into the chat. So if you go to that link that I just posted into the chat, you will see a page that looks like this. And right in the middle of that page is this Deploy to Oracle Cloud button. And this is a feature that connects GitHub repo to the Oracle Cloud and allows us to automatically run those provisioning or automatically provision stacks through Resource Manager in the Oracle Cloud. So this makes everything really easy for you. When you click that, it's going to take you to a new screen. It'll take you into your OCI environment. You want to click that you've reviewed and accept the Oracle Terms of Use. And then I'm going to make you do this here, which says that you've reviewed and accept the Oracle licensing agreement. To run an Oracle database in Docker, you have to have Oracle software. And to have Oracle software, you have to accept the license. Normally, you would have to go out and you would have to download this software on your own. And I'm cheating a little bit and making it available to you as not as part of the build, but it goes out and it pulls that Oracle database software down for you. And so just so that we're all covered on the license agreements, check that box. And once you do that, you'll get a little bit more information. It'll offer some different instance shapes here, so you can run it on a VM standard 2.2 machine. It will run on 2.1. 2.2 is just a little bit faster. And then you'll want to check this Show Advanced Options checkbox. And at that point, you're going to get some options here. One is whether you want to run this as a 19.3 database. You can also run 21.3. Both are available to you. Doesn't make any difference as far as the lab exercises and so forth are concerned. Either will work just fine. And then you'll also want to check this box, Run a Container. When you do that, it's going to offer you some options here, like the name of the container, the name of the database, the name of the pluggable database. This does create a pluggable database for you. And then also a host port for TNS. Now you see that says 11521. You're probably thinking, well, that must be a typo because normally we use 1521. There's a reason that I'm using 11521 here, which I will explain a little bit later. If you leave all of these as they are, you'll be just fine. Everything that we're doing in all of the exercises, everything you see me do on screen is going to match exactly to what you have. There's also another checkbox that should appear below this, which is generate an SSH key file automatically. Go ahead and check that. And it'll generate the key files for you automatically. There were some issues with folks before where they didn't understand how to create keys and so forth. So this will do it for you all automatically. And there's an opportunity to download that key a little bit later, which I'll show you. And then when you click the next button, it's going to take you to another page and you'll see a summary of everything. And down at the bottom, you want to make sure that this Run Apply is checked. and then click the Create button. And that'll take you to your stack job screen. It'll show you that the job is accepted. It'll show you that the job is running. Probably takes, I don't know, 3 to 5 minutes for it to run and get to this green screen that says, yes, it succeeded. And once you get this green screen, you may get this additional, in fact, let me set up my highlighter here. You may get this additional tab. It may show up automatically for you. It may not. If it doesn't show up, just reload and you'll see this tab. Click on that tab and that will take you to a summary page, which will show you the IP address, the public IP address that was created for your container, or for your instance that's running the container rather. And it will also give you an option for copying your public key, which you can then copy into a file in your local environment and manage, whether you're Windows or Mac or Linux, whatever your operating system is, manage those appropriately. Once we're here and once you see this is provisioned and that it says it's done, it's not. It takes about 15 to 20 minutes for it to go through the process, because it's provisioned at this point, the instance and so forth, but it needs to do a yum update on the environment. It needs to install Docker. It needs to pull an image from a repo that has the Oracle database built for you and everything. So there is a little bit more time involved. As far as connecting to the host, then you can use either of these commands if you're familiar with connecting to Oracle Cloud. If not, let me know and I can get you some instructions on how to connect via SSH to your environment using that using your SSH key. Once you've logged into your cloud environment and you're on that instance, there are a couple of ways you can tell whether or not it's done. The first is if you run this command Docker images and you see something come up. That means that at that point it's installed Docker and you have Docker on your instance. It's gone that far. If you don't see an image here, but the Docker images command works, just give it a minute or so to download that image. If Docker images fails, then it's because Docker's not installed yet. And then after you've run Docker images, if that works, run this Docker PS from the command line. And at that point, if you see up, that the instance is up and that it says that it's healthy, that means you have an Oracle database instance running in Docker on the Oracle Cloud in this environment, and you are good to go. So if you want to go ahead and jump in and start doing that, that's great. The information, all the instructions are also on that GitHub repo page that I shared with you just a few moments ago. In the meantime, I'm going to cover some of the things that are included in this build. So in your home directory, you're going to see a couple of subdirectories. One of them is Alpine. And Alpine, if you're not familiar, is a very lightweight Linux operating system. And we're going to use this to explore how containers work, because we're going to build a container on our own, just with operating system commands in just a few minutes. So Alpine is what we're going to use to do that. There will be a directory called Docker Images. Docker Images is the official Oracle Docker image repository. And you can use this to build your own images if you would like. And then this Docker lab is the repository that we're using for the lab itself. And so there are some scripts in there, there's the Terraform build files and so on and so forth. It will create an Oracle user in a DBA group. It creates a directory called Oradata, and this is where we're going to put our database files, and creates Git and Docker, does a yum install for Git and Docker to install those repos. So that's what this stack does. Now let's talk. If you're running this, we'll let that run in the background. I'm going to give you a quick background on Oracle, on Docker mainly, and how I came to start running Oracle on Docker. This started back in 2014 or so. My manager asked me to build out some databases on Docker, and I knew nothing about Docker. I'd heard the name a couple of times. Our developers used it all the time, but I had no idea what it was. So I reached out to some folks, some colleagues in the database world, and I started doing some reading and asked them, "Hey, what's this Docker thing? I'm supposed to be building databases in Docker." And there was a consensus from all of my friends that said, under no circumstances should you ever use Docker to run a database. And I heard all kinds of horror stories about, no, this is a terrible idea. You're going to lose data and your database is going to crash and it's slow and it's unreliable and all these horror stories. And so I went back to my boss and I said, no, this is a really, really bad idea. Here are some other things we could do instead, but please, please, please do not make me run an Oracle database on Docker, or any database for that matter, because it's doomed to failure. It's going to be a dumpster fire. And he says, well, it's not really my choice. We're going cloud native all the way across all the way across the company. So everything's going in Docker, no exceptions. And so even after threatening to quit at one point, I was like, okay, well, you know what? Instead of quitting, I'm going to go back and I'm going to do this thing. And I'm going to prepare my I told you so dance so that when everything blows up, then, obviously I was right all along. And this was a terrible, no good, bad idea. But a really funny thing happened. And that was that all these people that were saying, oh, Docker is terrible and you shouldn't run a database, they didn't actually know anything about Docker. And I began to realize that these were the same kind of really inflated doomsday sort of stories that you hear about other technologies. Like I remember when RMAN came out, and yes, I am that old. People said, oh, no, I've got all these shell scripts and I put my database, all my table spaces into backup mode. And that's the only reliable way to do this. RMAN is never going to be able to do it like a real backup, not like all my scripts. And, when automation advisors and so forth came out, oh, no, I want to tune rollback segments on my own because there's no automated process that can ever do that. I don't think I could tune undo now manual if I had to, because I'm so reliant on the automation. Same thing with virtual machines. I still to this day have friends that refer to the cloud as somebody else's colo that you can't drive to. And so, we have people who are resistant to change. And so they tell us terrible, awful stories about how things will go if we start adopting this new technology. And for the most part, they're not grounded in a whole lot of truth. So the real question is Docker really appropriate for databases, in particular, or Oracle databases? And well, Oracle says it is. You can run production databases on Docker for Oracle. And in fact, with 21.3, Oracle on Docker is supported for RAC as well. So you can run your production RAC databases in 21.3 in Docker containers, and you are fully supported. It is fully supported by Oracle. You will get support from Oracle support, and so on and so forth. So it is a fully supported, fully viable environment to run your database in. So there shouldn't be a concern about whether or not you can run your database on Docker. So if this is new technology to you, there are a whole bunch of new terms to know and understand. And I know that when I first started working with Docker, I was overwhelmed by all this terminology. And so when I do this presentation, what I want to share to you and communicate to you is that although there are all these different terms and all this new language, there are not that many things that are really important to us in order to do what we want to do. So you may hear things like images and containers and builds and Docker files and things about layers and overlay file systems and volumes and all these different things. So some of the really frightening things: stateless and stateful, ephemeral and persistent, rootless. Those are the ones that really scare database administrators, because you think, well, if my database is ephemeral, what if it goes away accidentally? We don't have to worry about that. We're good. Really, though, the only things that we need to worry about right now are understanding what images are and understanding what containers are. So let's put everything else aside. I want to start out and explain to you what a container is. So if you go on Google and you search for what is a Docker container, you will get this whole host of pages that come back that describe, to my dismay, they describe Docker containers as sort of lightweight virtual machines. That seems to be the common description. It's like a lightweight virtual machine. It's kind of like a virtual machine. Are they virtual machines? Are they like virtual machines? No, they are not. And it's really understandable that we compare them, because containers and virtual machines, or virtual guests, they let us do really similar things. They let us isolate environments, and they let us run in what appears to be a virtualized, in the case of Docker, what appears to be a virtualized environment. Certainly it is a virtualized environment when you're working with VM, with a virtual machine. But a lot of the analogies that you find when discussing and comparing Docker containers to virtual machines or virtual guests, they always seem to minimize or downplay the capabilities of containers. And so you'll hear analogies like virtual machines are buildings, or virtual machines are houses, and containers are apartments, or virtual machines are semi-tractor trailers, and containers are pickup trucks. All of these things tend to make Docker and containers sound like they're less powerful or less capable and somehow less serious or production ready. And that's very far from the truth. So what I want to do is I want to give you an example of what container versus virtual machine environment looks like in terms of a database. And so let's just imagine that we have three applications, and each has their own schema that we need to support. So we can approach this a couple of different ways. I know that there are more than just these two ways, but I'm trying to keep it simple here. You could do PDBs, dude. Yeah, no, we're gonna go real simple here. We're gonna say I have an Oracle Home installed, and I'm going to install brand new individual databases for each application. So here I've got database 1, database 2, and 3, and each database has its own set of metadata. And when I start it up, it gets processes, it consumes memory, and sitting on top of all that, I have my schemas. And each of these databases requires a lot of overhead. Or I can go and I can do it differently. I can say, well, I've got an Oracle Home, and I'm just going to create 3 schemas in that Oracle Home. And I have common metadata. I have a common set of processes. Yes, I need some more processes because I'm supporting 3 applications, and I'm probably going to need more memory because I'm supporting 3 applications. But I still just have essentially the same amount of metadata here as I have over here, except that over here I've got 3 times. I'm duplicating it 3 times. And so this is maybe a more efficient way of doing it. Because if you look at this and we draw a box around all of this, you see, well, for this, the 3 database model, I need a much bigger box, don't I, to contain all of this, because I've got all this extra stuff or all this duplicated stuff that I'm running in order to support these 3 schemas, which are the same either way. So let's carry that analogy over to what virtual machines and containers do. And with a virtual machine container, we both have this common host operating system. We'll just call that our Oracle Home. I have an abstraction layer. In the case of virtual machine, it's a hypervisor. In the case of containers, it's container runtime. But for each virtual machine that I have over here, I have a separate guest operating system. I have all of my binaries and libraries and dependencies and so forth. And sitting on top of that big stack, I have an application. Same thing here for my second virtual machine, same thing here for my third virtual machine. But with containers, well, my guest operating system is my host operating system. I don't need a guest operating system because my native OS is the operating system I'm using. So I don't have anything here, which means I don't need a hypervisor. I don't need to virtualize this guest operating system. And most of these binaries and libraries are going to be the binaries and libraries from my host OS. But if I need different ones, if I've got a dependency, something like that, I need special binaries, I need special libraries like we would for an Oracle database. All I've got to do is just provide only those. I don't need an entire operating system's worth. And then I have my applications sitting on top. If we draw a box around these, you can see, well, here we go. There is a lot of extra capacity left over if the box represents the power of the machine. So as a system administrator, I could put twice as much, let's say, onto this host and get the same performance from it. Or I could just scale this host down because I don't need as much power to get the same throughput, to get the same result from a container environment as I would with virtual machine. A little later, I'm going to show you how, even if we're running multiple Oracle databases, if I had 3 Oracle databases here, I'm actually not taking up 3 times as much space. I'm actually taking up, it could be no more space. I could have 10 or 50 databases running on an environment, and it would be footprint-wise the same amount of space for the application. I mean, I'm not talking if I had my data, set the data aside. But if I'm running Oracle Homes, if I'm running 50 databases and they all in 50 containers and all of them have, I've got 50 Oracle database homes, it could very easily end up being that I really am only taking up the space of 1, not 50. 50 is maybe an extreme example of how many database containers you might run. But we'll get to that in just a little bit. But this should give you an idea of what a container is. We're running natively on the system. And so what I want to do is I want to talk about how containers work, because there's probably still some misconception. And certainly I can show you all these graphics and everything, but it doesn't have the same impact as showing you how a container works and how really basic and simple it is. A lot of people are, I'm a little wary about containers because I'm not sure how the technology works and it seems a little, weird and abstract to me. But give me a virtual machine and I'm happy. And to me, virtual machines are far more confusing and have many more layers and areas where things can go south for you. So let's take a look at what containers really are. I don't mean to distill this down too much, but really a container works off of the concept of unshare. Unshare is a Unix command. It's been around for a really long time, far longer than Docker. Really what Docker did is they went out and they said, hey, you know what? We need an interface that makes this whole unshare thing easier to work with, and we can do really cool things with it. So that's what Docker did, is they wrapped this unshare into a more digestible, easier to use framework interface and gave us that. But unshare at its root, it lets us do some cool things. Linux has these concepts called namespaces. And namespaces are like little environments where different things work. So I've got a user namespace and I've got a network namespace and time sharing and process and mount namespace. And all of these different namespaces allow us to isolate and secure different things. And so when we start a container, all we're doing is starting a process. It's a Linux process. That is all that a container is. But we do a couple little tricks. And when we start that process, we say, we're going to start this process, but we're going to give it its own namespaces. And with those namespaces, we can say, I don't want this process to have access to everything on my system. So I want to give it access to some specific devices maybe. And I want it to have its own user space so that it can have different users than I have natively on my machine. And so you can do all of these things. And once you start that container and you jump into that container, you're inside that process. You can't see out, and other people can't see in unless you let them. And so if you're in that process, it appears to you, for all intents and purposes, that you are in your own little machine. And it's really cool because it gives you the isolation and the security and so forth that you would want to do. So the command, the really, really complicated command that you can do to run all of this is this here, this unshare command. But what I'm going to do is I'm going to jump over here to my my Linux host. This is a host that I just built using the same provisioning scripts that are in that GitHub repo that I showed you a little bit earlier. And what I've done is I've just navigated down into this Docker lab directory. And here I've got some scripts to run. So I'm just going to run this lab1 shell script. And the reason I'm doing this as a shell script is just because it lets me, I don't have to type the commands because I'm lazy, but it'll show us some different things. And so I'm just going to walk us through so that you can see everything that this does. So what I've done is this script is running this command unshare user. And so I've unshared this user and started a process. And you can see my process ID here is 21149. And my current directory is this Docker lab directory. And I see that I'm on this host and that I'm running this different operating system and so forth. And what I want to show you here is that my user ID, so when I ran the command ID on this system, it came up and it said, your user ID, I have no idea who you are. It assigned this NFS nobody. Same thing for my group. I'm NFS nobody, which is on Oracle Linux, it's its way of saying, I give up. I don't know who you are. So this is what I do. What happens if I run this unshare with just the -- user. So all I'm doing is unsharing the user namespace. Now, if I rerun this command and I add this map root user, you can see now, oh, hey, you are the owner of this process. So because you're the owner of the process, I'm just going to call you root now because you own this process. You're the one that started it. So you're the root user. I'm not really root. I'm the OPC user in this environment, but we map the root user to my local user ID. So now it's happy. It says, oh, now I know who you are. You're root and you're in the root group. Okay. You can see my process ID is 21423. It's a completely different process. So it's a different container now. Present working directory, all that other stuff remain the same. So now we're going to do something and we're going to say, now I'm going to unshare my network namespace. And so before I have, when I do IP link show, I get this result. But now I can do this, I can run IP link add type veth. And now you see, oh, hey, look, I was able to add Ethernet adapters. So I have my own network. And now I can do my user timeshare. User timeshare lets me change my host name. So my host name before is Docker Lab Compute. I can change my host name to Alpine if I want. And it picks it up in this container. So I'm changing all these different things. I can get my own set of processes. This is all that my container, all that this process is aware of. It just knows me. It doesn't know about everything else that's running on this system. And this is the same system That's everything that's running on the system. So there's a lot more on this than what you're seeing here. And it's because this process only knows about itself. And you'll also notice that my process ID changed. Even though I'm not really process 1, I'm process 21 something or other, it thinks that I'm PID 1. So here's one more command. I added a bunch of different things. I said, oh, I'm going to let you fork things and mount drives and mount the proc namespace and a bunch of other stuff. And I'm also changing my root directory here. So when I change the root directory, that's a way of saying, I want you to look here in this directory and start everything from here. And when I did that, it came up and it said, I can't run bin bash. I don't know what we're doing here. I can't run bin bash. Well, why is that? Clean this up. Well, I changed my root directory to this Alpine directory. And where is bash? Yeah, no, it's not there. Because there's no bash in Alpine. Instead, it's called ash. So when it went and it said, oh, hey, we're going to run bash because that's my default shell, it says, oh, I couldn't find it, don't know what to do. So we're going to change this command just a little bit, and we're going to add and say, and I want you to run this command. I want you to run bin ash. And when we do, now everything starts showing up. Now I'm running in an ash shell in this environment. So there's a kind of a quick example, a quick run through of how that unshare command works. This lab is in the it's in the repo that you're able to download, and you can go through and you can explore that a little bit more. There are all sorts of neat, cool things that you can do with this unshare command. And I think I learned more about working with containers. Or, I'm sorry, more about Linux working with containers because I started investigating and discovering all these really cool things that you can do with this unshare command, and how you can mess with people if you want to make them think, hey, where'd all my stuff go? If this is interesting, I'm sorry, I skipped one slide ahead. So containers, we don't have a hypervisor. There's no operating system because we're using the native operating system. There's no boot process. There's no init process. Starting a container is just starting a process on my host. All of my isolation, my security is handled through native Linux constructs like namespaces, and I have very, very minimal dependencies. Whereas virtual machines, still talking about the difference between VMs and containers, I have that hypervisor, I have an additional operating system, I've got to boot that operating system if I want it to work. I'm working through some sort of virtualization. My isolation is through the VM. And again, we've got a full operating system or file system that we're working with that we need in order to have something that's working for us. So those are some of the differences. If this kind of thing, if you find this fascinating like I do, there are a whole bunch of different ways that you can explore building your own containers. And here are a couple examples. I'm sure you can just search on Google and you will find dozens of them. How to do it in Go, how to do it in Bash, all sorts of different things. So it's really fascinating. I don't want to go too far down that rabbit hole. But the next thing I want to show you is the containers are really fast. And so I have another lab here. If I could type. So this is a lab, and I'm going to show you some examples of how fast Docker is. So what I've done here is I ran a Docker images command, and this is going to show me all of my images on my system. I know I haven't talked about what images are quite yet, but I will get to that in just a minute. But right here, you can see I have an Oracle Database 19.3 image. That's the only thing that is on this system. I'm going to run a command here. This is docker run -it Ubuntu. Docker commands are pretty straightforward and pretty self-descriptive. When I say docker run, it means I'm running a container. I'm running a process or starting a process on my system. The -it says I want to have an interactive session with TTY. So I want a shell is what I'm saying. And I want a shell. I want to connect to the container while it's running. And this very last thing here is Ubuntu. It says I want an Ubuntu image. So I'm going to hit enter here. This is going to start this process for me. What it's going to do is it's going to go out and it's going to say, Ubuntu, I don't have an Ubuntu image on this system. So I'm going to go get one for you. It'll go out. It's going to grab that Ubuntu image. I'll tell you where it comes from in just a moment. It's going to grab that Ubuntu image, download it onto my system over the internet, start an Ubuntu container, and give me a shell prompt. Okay, couldn't find it locally. We'll download it. Boom, boom, boom. And there you go. Now I am in an Ubuntu machine. It appears, you would think, I mean, that looks like Ubuntu. But if I type exit and I jump out here, you'll see, and I'll show you in just a second here, that I am really on an Oracle Linux 7 system. You see that now I have this additional image. 72.8 meg is all that Ubuntu is. And so as long as it took, if you see here, you say, okay, I couldn't find this Ubuntu image. It pulled it, it downloaded and everything, and it started my system up. You thought that was fast? Watch how fast it is when I already have the image stored locally on the system. When it's already available to me, I'm going to run that same command, and there you go. That is an Ubuntu prompt that quickly. Because all I'm doing is starting a process on the machine. It's like opening a Word document, except faster in this case. My machine doesn't open Word that quickly. And that's how quick you go. This is not the same container. This right here is the container name. So I've got D88BDF, whatever, and this next container is 9488. It gives really descriptive container names. So it's intentional. We don't give containers names typically because they're, for the most part, we run them as resources, something functional that does something for us. And now when I look and I say, all right, what are the containers that are available on my machine? You can see I have these two containers and they both ran the bash command. And it did give these names. Docker generates random names if you don't assign something to it. And so those are the containers that were created in my environment. And it's that quick, it's that fast to start them. Okay, so that's neat. But what about for an Oracle database? So I want to give you an example of how fast it is to start and stop or to start an Oracle database. And that's because I have this Oracle database container. This is a container that was started from that Oracle database image that I showed you earlier. And you can see here that it is stopped. It exited 2 hours ago. So I'm going to run a command here, docker start Oracle DB. And that tells Docker I want to start this container, but I'm going to tie another command to this. And that's this docker logs command. So docker logs says I want to see the logs of my container, and -f says I want to follow it. So it's like tailing your log files. And in the case of the Docker containers that Oracle built, and these are built from Oracle's images, the log, once a database is created, the log is the alert log. So if you're running an Oracle database container and you want to see the alert log, well, you can do it straight from Docker. You can just do docker logs -f and see your Oracle alert log instantaneously. So I've got these two commands strung together. And the very first thing you're going to see is you're going to see the tail end of the alert log that showed the database shutting down. But right after that, you're going to see the listener starting and you're going to see the database starting. And I want you to appreciate, if this were a VM, if I had to boot this VM, it would start the operating system. And once the operating system was started, it would start running Oracle and start the boot up process for Oracle. Not so with Docker. There's the listener starting, and here's the database starting this quickly. This part doesn't take any less time or more time than it would on the same hardware. So there we go. Database is ready to use, and this should look familiar if you've used a 19C database. This is the alert log, and the database at this point up and running. And in fact, I can rerun this this Docker PS command. Now you see that it says that it's starting, and it's because there's a 5-minute. It takes 5 minutes before the health check goes and says, is the database really up? So we'll see this will be healthy in another 4 minutes or so. And so it's going to give us some information about the running container. If you didn't catch that, this Docker PS, I'm using PS just like I would use on a Linux operating system to list processes. So Docker PS lists running containers. I see that one. If I do Docker PS-A, oh, you can see here it came up and it met its first health check. So now it's healthy. If I do Docker PS-A, it'll show me all of the processes, whether they're stopped or started. So with -A, you can see I have these additional containers. These are stopped containers. I could restart these processes and have these containers come back if I wanted to. So Docker PS versus Docker PS-A. So containers are really fast. And certainly a lot faster to start up than a virtual machine. Yes, I know that there are VMs that start super fast because they operate a little bit differently. We're talking, I can never remember if they're type 1 or type 2 hypervisor, but we're talking the common hypervisor, not the other type. But still, your containers are going to be faster starting up 99.9% of the time, I would venture a guess. Okay, so we talked about what containers are, that they are not virtual machines. They're just processes running on a system. So what is an image? An image is just a set of directories, a set of files that we use. It has a little bit of JSON instruction. It's basically a big tar file is all that a Docker or container image is. It's just a tar file, just a zip tar file. And it has those JSON instructions in it that say, this is how you start this, and information that Docker needs on the back end to do what it needs to do. Some things that we should know about images, though, is that they are stateless. When I say that an image is stateless, it means that I can't change that image. So once I've built an Oracle database image, I've installed, let's say I've installed 19.6 or 19.9. I can't go in and change that image and say, oh, now I want 19.13 or I want 21.3. You have to create a brand new image for that. And you probably think, well, that sounds like a lot of work, a big pain in the neck to do. What's the point of it being stateless? Well, the wonderful thing about images being stateless is if I have an image for a 19.6 or a 19.9 database, that image is now an artifact. And if that image, if that artifact of my 19.9 database runs a particular way in my test environment, and I use that same artifact in my dev environment or QA or production, I know that I have exactly the same database software, and then it will behave the exact same way. And that is the beauty of stateless images, is that you're assured that they are going to be the same. Images are something that we run. We run an image to get a container. Whereas containers, just a process. Containers are stateful, so I can go out, I can make all the changes I want in a container. I can go, I can add files and remove files and do all sorts of neat things, update, add data, delete files, install things if I want. And over the life of the container, all of that information will persist. It will stay there. I can stop that container. I can stop the host. I can start it back up. It's all there because all of that information is stored on my local file system, on a shared file system. So if you have an Oracle database and it stores its files on NFS, and you run an Oracle database in a container and store files in NFS, they're being stored exactly the same way because it's the Linux operating system of the local host that's making that interaction and saying, I'm putting it on NFS, I'm putting it on my local file system. And so there's nothing different in the way that those files are stored or managed or persisted that will cause, and this is a big area of concern that some people are, oh gosh, their containers are ephemeral, they'll go away. You know, what if it goes away by accident? Yeah, you can persist your data, absolutely, and it's going to stay there same way as it does in a regular operating system. So again, images are stateless. We can't change them. A nice way of thinking about it is like in our demo here. One of the things that I download is this Alpine image. And if we go and we look at the Alpine directory, you know, this looks like an operating system. I've got all the directories that I would see in a normal Linux operating system, right? But this is just a directory on my machine. It's not like this bin in the Alpine directory. It's not the bin directory. It's not the Etsy directory. It's just a directory in my local home directory. So it's not the one that we're going to. But I downloaded this from Alpine. I went out to this link. I did a wget. No matter how many times I do this wget, I'm always going to get the same tar.gz file back, right? Well, that's an image. It's because we want it to be fixed. And if I go here and I delete my var directory or something like that, it doesn't change the tar file. So I can re-download that tar file. I can, you know, uncompress the tar archive on my system, and it's going to recreate those directories for me exactly the same way every single time. So that's basically what an image is, and should give you an idea of how they're stateless and why it's important for them to be stateless. So I can go and I can make my changes. It doesn't affect the original tar.gz file. It doesn't affect the contents out on the Alpine linux.org website, nothing like that. So images give me this this very reliable way of getting back to the same starting point every single time. Containers, stateful, I can go in and I can change those. I can do all sorts of different things to them. One of the big concerns that people have is they hear the phrase containers are ephemeral, and that is scary for database administrators. And that's true. As soon as I delete a container, anything that I created inside that container goes with the container. But there is a neat trick that Docker or containers in general introduce that let me persist data outside of the container. So even if I delete the container, all of my data remains behind. And it's a neat trick I'll show you in just a few moments that lets us do some really, really cool things with Oracle databases that you cannot do, at least not easily, with any other technology, whether it's virtual machines, whether it's native bare metal operating systems, what have you. Okay, so this is great. You know, containers are neat, and now I've got an idea of what containers and images are and so forth. Yeah, what's the selling point? Why would I want to run an Oracle database on this? Well, how is it different or better than running it on my local machine and just installing Oracle natively? Well, Docker does some things for you that are really compelling. First off, it's portable. So the Docker images that I create on my Mac, or I've got a little Linux box sitting underneath my desk, create on my Linux machine, or that somebody else creates on a Windows machine, they'll run on any system that supports Docker or containers for that matter. There's a standard called the Open Container Initiative, not be confused with Oracle Cloud Infrastructure, but that OCI standard, any Docker container will run on any other OCI certified environment. So what I put on or create on my Mac, I can send to someone running a Windows machine and behave the exact same way. No different. It's also infrastructure as code. So it's versionable. I can put all of my changes into a repository. I can see exactly, and I can duplicate exactly how that image was created. And because I've got them in a repo, not only can I distribute that infrastructure as code, as that source code, I can also distribute the images. In fact, earlier when I did that Docker run Ubuntu, if you recall, Docker says, well, I don't have Ubuntu locally, and it didn't come as part of the Docker install. It goes out to the Docker hub, and it says, is there an Ubuntu image out here? Yep, there certainly is. And so it grabs it and pulls it from that Docker hub, which pulls it from a set of official or certified images that Docker provides. So highly distributable, highly versionable. We've got tremendous visibility into things, and it allows us to do very repeatable tasks with our databases over and over again, very, very reliably. Again, anything that I run or build on my machine is going to work on a Windows machine, on a Linux machine, another Mac. Doesn't matter what the version is. It'll work on OCI. It'll work on Azure, AWS, Google Cloud, whether you're running Docker, Podman, Docker Compose, Kubernetes. Doesn't matter. It's all part of that standard. And so it's tremendously portable and very, very reliable in that sense. If you've ever seen this meme, it works on my machine, then we'll ship your machine. That's what we're doing. We are shipping the working version. And so if you have, a bunch of different environments and you're managing all of that manually right now, well, with Docker images, you just drop that image into your environment and you run that image. You are going to get exactly the same container in your test environment as you have in your production environment, what have you, whatever the source was for that image, we can duplicate it very, very reliably everywhere. And again, we're taking up a lot less space. Some of the things that I use Docker for one thing, I can eliminate dependencies because I can run Oracle databases locally on my Mac. I don't have to have a Linux operating system. I don't have to install VMware or VirtualBox or anything like that. It just runs natively on my machine. I do a lot of testing of SQL and PL SQL scripts, shell scripts, and so forth. It is fantastic if you want to hack at things and experiment and learn to do new stuff. Performance tuning is a really cool thing. I can make a Docker container on a laptop look like a 50 terabyte database if I want, just by exporting statistics and metadata from that production, from that big database, importing it into a local container. I can do a lot of performance simulation there and make that local database think that it is much bigger than it is. One of the really neat things that you can do with Docker is this troubleshooting and replaying through different scenarios. Ran into a bug with DataGuard FarSync a few months ago, and it was just tremendously difficult to explain and even harder to reproduce. So I just built an environment with Docker Compose for containers, and I can just kick that off and start fresh every single time. I know because I've created that problem with that infrastructure once, with that automation. Every single time I am starting over from that same spot. And it takes like 15 minutes to spin up 4 databases, to create 4 brand new databases, populate them, configure DataGuard, and all I've got to do is step away and get a cup of coffee or take a walk with the dog, something like that. And when I come back, everything's done for me. So I don't have to go through and worry about missing a step or anything like that. So it's really incredibly useful and powerful for things like that. There are a few things that Docker does not do tremendously well. Enterprise Manager is one of them. And it's not that Docker doesn't do it well. It's that Oracle wants to hard code host names into the Enterprise Manager build. And that makes it really, really tough to start containers that are all going to start with a different host name when they start, and it's that randomized host name. So there are some challenges. Rack is supported on Docker, and you can do Rack on Docker. I still think that it's easier to do in Vagrant if I'm doing it locally. Same thing with ASM. But it's not impossible. It just seems a little bit less troublesome for me to do Rack and ASM in Vagrant. AHF, Autonomous Health Framework, used to be Trace File Analyzer, can be a little tough to do in Docker, although I have a Docker image working now that has AHF, but it was a little, you had to pull some tricks to make it work. So again, there are some things that may be a little easier to do elsewhere, but Docker on its own is a fantastic tool and great for doing all sorts of things. So let's talk about, with all this background out of the way, let's run some Oracle on Docker. I know it's about time, right? The beauty of this lab is that it will provision everything for you and do everything for you automatically. But if you want to do this on your own, and you want to be really hands-on and see the process rather than having the end result, then this is how we would go about doing that. I'm going to run through this real quickly because the slides are available and has all these as individual steps. These are the commands that I use for 80–90% of what I do in Docker. Even after using it for 7 years, this is the majority of what I do. These and start and stop. Within this slide deck, there's a complete command reference at the end that's like a glossary of, if you want to do this or you want to do that with a Docker container running an Oracle database, it has all of those commands built into it. So again, I don't want to dwell really heavily on the commands, anything like that. So we have, in this environment, we have a container that is running. You saw that just a few moments ago, that Oracle DB container. How do we log into it? We run this command docker exec. Docker, I want to execute something. -it means I want an interactive TTY shell, so I want to log into it. I give it the container name. In this case, it's Oracle DB. That's the default. And then I say, and this is the command that I want to run. And I'm going to tell it I want to run bash. So it's going to go and it's going to look and see, can I find bash? And it's going to be in the path. And so it'll start a bash shell for me. I could run SQL+. I could run any command that you would run in an environment. I could string onto the end here if I wanted. But this gives me a shell that I can log into. So I want to, we'll show you real quickly here. So we'll just run that command, that Oracle or Docker exec. And here you can see that I'm logged in. I'm the Oracle user right there. This is my host name. And you can see I'm in the home Oracle directory. And if I want to see what's running in this environment. Oh, I've got an Oracle database. I can run SQL+ from here and connect to my database. This is an Oracle database. There's absolutely nothing different about it than an Oracle database that I was running on bare metal in a huge enterprise data center. Exact same Oracle database. So that's how you can run commands. You can log into that container. And so this is essentially like doing an SSH into your host. I can connect clients as well. You remember earlier I showed you that I've got that 11521 was the port that I had set up. It has to do with how I created this container. And so if I wanted to connect to this database from my local machine out to my database running in OCI, in the Oracle Cloud, I can do that. All I've got to have is I've just got to know my username and password. I have to know my host name or my IP address, and I'm going to use that port, that 11521 port, and then the service name, which is going to be Oracle DB. Oh, I misspelled that, didn't I? And give you an example of what that looks like. Here we go. This is that container that that I just built earlier this afternoon. It's my IP address and my port. I'm going to connect as the system user. I guess that is the correct service name, isn't it? And now I can connect to it. And in just a second, SQL Developer is always really slow for me. So I can connect to it and I can see, oops. I don't use SQL Developer that much, sorry. Oh, it's just host, isn't it? That's why you don't do live demos. Wait. There we go. Oh, host name, of course. You know, someone's sitting there in the background going, it's host underscore name, idiot. So here, that 41E, 7C, and if I switch back over here, this is why I had scripts to help me out with this. So you can see it's the same host. I'm connected from my local SQL Developer instance to my OCI database. And again, when we're talking about that port, you can see here that this is my host. And right here, you can see that I've mapped 11521 on my local host to port 1521 in the container. So my container is sending all of its traffic. It's like a NAT translation, sending all its 1521 traffic onto 11521 for me. So I can connect my local clients. Building images, this is something you don't have to worry about doing because the Oracle scripts do it for you automatically. But to do this on your own, if you want to do it on your local system, the first thing you want to do is go and download Docker. Links are in the repo, in the presentation. Then you want to go to this Oracle Docker images and follow the directions to pull this or clone this repo. You want to download the Oracle database software, and we are going to download it for Linux x86. Doesn't matter if you're on Windows or Mac, we are downloading the Linux x86 because that's what Docker is going to use. We're not going to unzip that. Here we've pulled this Docker images repo. We don't unzip that after we clone the Oracle repo to our local machine. We're going to move that downloaded file into this lengthy subdirectory. And in fact, I'll show you here on my local machine. So this is the directory that we get from cloning that repo. And I'm just going to navigate down into the Oracle database, single instance, Docker files. And now you see I have all of these different directories for different versions. And underneath my 19.3, you can see that I have some files here. I don't have the zip file because I didn't build it from the zip. I built it from an existing image, but this is where you would put that zip file. And that directory that I just showed you lets you do some neat things like customizing your image. And so you'll see that there are several different scripts in here. I have a script that installs my database binaries, that creates a database, that sets the password, that sets up Linux and so forth. And these are all just bash scripts. So I can go into those and I can do different things to customize my database build. I have a response file template, so I can change the way that my database is created if I want. All sorts of different things that you can do here. Again, there are bash scripts. So if you're familiar with bash and have done the scripting in the past, this is all going to feel fairly familiar for you to jump into and work with. So once you have all of this set and you've made any modifications that you might want to make for your scripts, for example, one of the things that you'll notice in Docker is that Docker images tend to be really, really pared down. So here, do I have my so one of the things that that we can do here is maybe I want to VI this file, and it says VI, command not found. It's because VI isn't installed typically in a container operating system. And the reason for that is that containers, well, we're running thousands of them. We don't log into them. We manage them remotely. So if you're not logging into it, you're not going to edit files, are you? So you don't need VI, and you don't need less, one of my favorite file viewers. Those aren't installed natively on the system, but there's no reason that you can't install them. So I could go into the scripts, set up its environment, and you see down here, I've got a yum install command that's running. Well, I could really easily add, VI and tree and whatever else I wanted to add that wasn't natively part of my image. So there are all sorts of different things that I can do here if I wanted to. Okay, back to the show. So building an image, the Oracle script does all this for you automatically. You just have to run this build container image, give it a version, and give it an edition to run. So it'll run Enterprise Edition here for 19.3. And this is all that these scripts are doing for you in the background. And then you wait, depending on the system, might take 5 minutes, 15 minutes, just a matter of how much power you have available for that process to run in the background. There is a way to shortcut this. You can go out to Oracle's container registry and log into the container registry itself. And from here, you can go to, it's been too long, hasn't it? You can go to the database directory and you can pull different database images. And if you're logged into the container registry, it'll pull these down for you automatically, just like we pulled them down from the from the Docker Hub for that Ubuntu image. So you can go out and you can pull these images. You do have limits though. You get 19.3, 21.3, 12.2, and 12.1. So you can't get 11G. You're not going to get all the different little point releases. So if you wanted 19.13, you need to build that on your own. You're certainly not going to get it from this repo. But if you do need 21.3 or 19.3, whatever, then this is a way of getting it. Something that I will note for you. So you can go to the Docker Hub here. Wait, where is it? Oh, here we go. Let me just do this. So you can go to Docker Hub and you can download these official images of all these different things, whether it's operating systems or something pre-built with Ubuntu or WordPress, whatever it may be. You can get these official images and these verified publisher images, which are trustworthy. But you could also, this is a community site, so anybody can upload an image to this site. And what you want to be wary of is you go and you're looking on the Docker Hub and you see, oh, look, here, somebody's got an image for database 22Q. Yay, I'm going to download this. Yeah, you want to be really careful about that because you're essentially downloading something that runs with elevated privileges on your local system, and you may not be getting what you think you're getting. So if it's not a verified publisher, if it's not an official image, be really wary of what it is that you're downloading. I showed you a basic command to run a container before, and this is a basic command to run an Oracle database container. You'll notice that before I ran -IT, here I'm running -D. And -D means I want to run it detached, so I want to run it as a background process. When I ran that -IT, the container was associated with my process being logged into the process, me running the process. As soon as I exited that process, the process died. When I run with -D, it runs detached in the background, and so my database will run whether I log out of it, whether I log in and log out, so on and so forth. Now, this will give you a really basic database container, but it's probably not everything that you want. You probably want a little bit more. And so this is the command, or very similar to the command that was used to run the container in the provisioning script in this Terraform stack. And we have this same run -D, but I gave the database here, I'm giving the container a name, telling it I want it to be called O193 instead of letting Docker assign a name. I'm telling it that I want to map ports, that this local port on my machine is going to be associated with the 1521 port in my Docker container. And then this -V says I want to map a volume. And so I'm going to map this directory on my local system to the opt Oracle or data directory in my database container. And this opt Oracle or data container is, directory is the default location where we put all of our data in an Oracle database container image. And this is going to come in really handy. I'll show you in just a moment. And then I can provide a whole variety of different environment variables with this -E, so I can have multiple -Es. In this case, I'm giving it an Oracle SID. I can give it an Oracle PDB name. I can supply the password if I want, and so forth. And Docker run commands, where I'm saying I want to run an image, they always end with the name of the image that I'm running. And here I have this image coming out of an Oracle repository, and it's the Oracle database image. And the tag, everything that follows the colon, is 19.3.0-EE. It tells me it's a 19.3 Enterprise Edition. And this is the command that you could use to run a useful container. Oh, rather than highlighting it, I had everything spelled out here for you. I mentioned that there were some options for setting the environment. Again, you can set the the password, not present working directory. Set the password, the SID, the PDB name. You can set the character set. There are a whole bunch of these that are described in Oracle's repo, but these are some examples. Couple tips and tricks. Okay, I want to show you. I mentioned that volume, and that the Docker container images put all of their data under this /opt Oracle or a data directory. And I mapped that to something locally on my host. In this case, I mapped it to this directory /oradata/Oracle DB. So it's like an Oradata's root directory. And then I said, and I want to have a subdirectory for my container. Oracle DB is my container. And if I look, I see I have a DB config directory and an Oracle CDB directory. And I don't have tree installed. If I look under this Oracle CDB directory, I see what I would expect under a regular or a data directory, that's not running on ASM. I've got my control files and I've got my seed files and my pluggable database files, control, and so on and so forth, redo logs and everything. What's this DB config directory? That's kind of interesting, isn't it? Oh, it's got a subdirectory for my database. Oh, what's in there? Huh. I've got a listener.ora. I've got my password file, my Aura tab, SP file, TNS names file, all of my networking files stored in this weird directory that doesn't normally exist. And if we go into a container and we look at that directory structure, we see the same thing. But we also see, logged in, if I go to my Oracle Home admin directory and I list my files, you can see that my listener.ora is linked, soft linked over to that file. So my Oracle Home is part of my database image. And if I were to and it's part of my container as well. So I'm running my container and I have my listener.ora and my password file and SP file and so forth. They're all underneath my Oracle Home. And those directories are all part of my container. And so if I make that container go away, if I remove my container, those configuration files go away. Even though I may have saved my data, all my data files onto a local file system, well, the configuration information that goes with them would have been lost. But by mapping and linking these over to my Aura data directory, all of this configuration information is saved. So I can delete this container. And because I preserved or persisted the data into this Aura data directory, into this volume on my local machine, none of that data is lost. That data stays behind. So I could delete this container and I could start a brand new container using the same commands, so the same database SID and so on and so forth, and map it to the same directory. Well, this wonderful thing is going to happen. Oracle wrote all these neat scripts that say, I am a brand new container and I'm starting up. I should check and see if I already have data out there. And it's going to go out to that directory that you told it to go to, and it's going to look and see, oh, look, I've got configuration files. I'm a database. I must have been here before. And it's just going to start. Even though it's a brand new container, it sees that there's data already there, and so it'll start. And we can use this to create an instant database because we have all of the configuration that we already need to start that database. So I can do something really cool since all of my files are in this directory. Well, I can go and I can copy those files. I don't need to do like rman commands or anything like that. And these two commands are something you only need to do in Linux environments, just because the permissions are gonna be a little wonky. I can just copy this directory, this Aura data directory, to a brand new directory. And now I've got a gold image of my data. I want to make sure there's a recent versions of this. Look for this checkpoint file, this hidden checkpoint file. This threw me for a loop a few weeks or a couple of months back when I was doing this. Look, hey, it doesn't work anymore, but just make sure that CDB file is the Oracle CDB created file is there. So we create that copy of our directory, and now we take the same command we had before. We just need to change our container name. It has to run on a different port because I can't have two databases running on the same port. I change my volume, the location of that data, and now I start this or run this brand new database. And instead of going out and creating a new database for me, it's just going to pick up and assume that it existed all along. So I can clone this data. I can take backups of my databases and just, like, I've got a gold image of my database. Let's say that I'm doing an upgrade. I'm working on upgrades. So, I keep failing at this particular step. We'll copy that data from step 5 into another directory. You go, you run your upgrade, it fails again. It's like, okay, well, I don't have to go back to step 1. I just restore step 5, my gold images from step 5. I start my container, and it's going to come, and it's going to be right exactly in the same spot that it was. So it's a shortcut. If I'd like, I can have QA data, dev data, different versions of data available to people, all stored as this complete, distinct, separate collection of data. One thing that I will note for you when you're doing this, when you want to do this trick, make sure you're using unique paths, because if you have multiple containers running on your system, multiple databases, if they're all using the same directory, then you're going to have potentially multiple control01.ctl files and system.dbf and so forth, and multiple containers trying to write to them. That's a bad thing. You don't want to do that. So keep those separate. Let me check here real quick and see. Looks like there are no questions. So I'm going to talk real briefly. Remember earlier I said I could run 50 Oracle databases on my system, and they would take up no more room as containers, data separate. They wouldn't take up any more room than if I had one, potentially. Well, how does that work? Well, it works because Docker has this principle known as an overlay file system or a union file system. And it's part of why our containers start so quickly. Even though my Docker image is for an Oracle database is maybe 6 or 7 gig, it doesn't need to take that image and copy it somewhere. When I start a container, it starts the image. It uses the image as a file system, and it begins with the image is my lower layer, and starting a container creates an upper layer and a working layer on top of that. And it's kind of like, I like to think of it as looking through a table, looking through a glass table. And so if I've got a glass shelf, and down on the very bottom, I have file 1. And I don't put anything in between me and file 1. Well, up here at the working layer, I see file 1. If I do put something between file 2 and me, well, now I see whatever is at this level. All that my container is, the only space that the container takes up is whatever changes are made in this upper layer. And the Linux operating system takes care of doing the diff, essentially, and presenting a working layer to the container. So if I have 2 Oracle databases that are running from the same image, they're both using this same lower layer. And then they have their own individual upper layers or middle layers, probably a better way of thinking about it. And only the files that are changed between the original and what was created in this container, those are the only files that take up space for that container. So if I don't make any changes in this upper layer, well, whether it's 2 containers or 50 containers, this working layer is virtual. This is real. This is real. And if there's nothing here in that middle layer, I've made a lot of lines. If there's nothing there in that middle layer, this working layer is going to look at the exact same content for every single container that I have running. So even though I might have 2 or 5 or 50 databases or 50 containers running in my system, if I'm not making major changes to them, they're not taking up that much space. It's a really fantastic, extremely efficient way of doing that. And we're getting a little short on time. This is how you would create that overlay or union file system if you wanted to do it as a command. And you can certainly do it in the environment that you have here in the hands-on lab if you would like. Alternative repos, I have my own Oracle repo that I run. I think it's really cool because there are some things in Oracle's repo that I don't like. there are all sorts of things, all the things that I feel like, Oracle doesn't do this in theirs, but I want to be able to do that because I run sometimes some more production level things that maybe the Oracle repos aren't appropriate for. I do a lot more builds. I do some really customized, specialized builds of images. One of the things, like, it bothers me that the Oracle images don't respect optimal flexible architecture naming conventions. All sorts of different things. I've got some data guard and farce sync labs that, or a provisioning out there that's available. So this is just my personal plug for all the cool things that my repo does. If you want to explore it, be my guest. If you have suggestions or run into problems, I'd love to hear them. And that is it. We'll jump into questions here. This is my contact information. So if you come up with a question later on that you would like to ask, please feel free to reach out to me, send me an email, or contact me on Twitter, LinkedIn, whatever it may be. I am more than happy to talk Docker and Oracle. I love doing it. People give me hard times, like all my coworkers. Oh, Sean's talking about Docker again. Yeah, we'll just put it all in Docker. But I really do. I think it's a wonderful tool. I hated it at first, and now I cannot imagine my life without running things in Docker. It truly is a wonderful tool. So if you have questions, feel free to reach out. And with that, I'll turn it back over to you, Frankie. Francisco, you there? Oh, and I see you connecting.
Yes. Good. Now, I was talking, but I forgot I was on mute. And that's something that happens all the time. I cannot see any question coming at the moment. If anyone has any questions, please feel free to ask, and Shen will be more than happy to answer. Also, if anyone is watching this on the replay, you can easily reach in to his email or his Twitter handle, and he'll be able to answer any questions from this session. Very interesting, very detailed presentation, Shan. Congratulations. Very interesting.
Thank you, and thanks for hosting me as well.
No, thank you. Looks like no one have any questions. In that case, thank you so much for dedicating a late afternoon from you to share your knowledge and this content with the Asia Pacific, and not only Asia Pacific, we have people around the globe, globally, audience. And please take care and be safe, Sean, and everybody else.
My pleasure. Thank you very much. Thanks everyone for attending. Appreciate it.
Thank you so much. Have a wonderful afternoon, evening for you, and good morning, good afternoon for everyone here in the Asia Pac.
Great. Thanks again.
Bye-bye.
Bye.
CloudDB, shaping your new normal.